Hey guys, welcome back.
Oh, I'm sorry, Miss Graham. Just
Get your calculator.
yeah, just wanted to make my calculator
We
ready.
got to be prepared. So Miss Uwe grabbed her calculator.
Yes.
You better grab yours.
Mm-hmm.
Because now we're going to talk about measuring temperature. So get your staircase out. King Henry.
Oh yeah.
Yeah,
King
get your
Henry.
staircase
Where's my
out.
King Henry?
Yeah.
There's my King Henry.
There. You might need that.
Yeah.
So first let's talk about the difference between heat,
Heat
and temperature. Because they are not the same. Of course they're related, but they're not the same.
Yes.
So the energy an object has due to the motion of its particles
Is known as heat.
heat.
So
Right.
motion, heat.
Right, and a lot of students will recognize the energy of motion is kinetic energy,
Mm-hmm.
right?
Yeah.
So to measure the average kinetic energy of an object,
That's what we call temperature.
Yeah. And so, of course, these are related.
Mm-hmm.
But the difference is a larger object can have the same temperature but a different amount of heat than a smaller object,
Oh yes.
right?
Mhm.
Because it has more particles.
More particles.
Yeah. So we're measuring the transfer of heat from one object to another when we're measuring temperature.
Yes.
It's flowing from one object to another. So what direction does heat flow?
Yeah, movement of heat. Heat always moves from
From the object with the
high.
most,
High to low.
yeah, to the object with the least.
Yes.
Kind of like diffusion and osmosis in biology.
Mm-hmm.
If you're moving across a membrane, you go from high to low.
From high to low.
And that doesn't take any effort at all. It just naturally goes that way.
Yes.
Yeah.
Mm.
That's why they call it passive transport.
Mm.
Okay, so an object would do what? If you heat it up, what's it going to do?
Tends to expand.
Yes, because it makes its particles move faster
Mhm.
and collide with each other more.
Yeah.
So they would expand with an increase in temperature. And of course, when temperature goes down,
It contracts.
it contracts. Right. Clear the writing. There we go. So when we're measuring temperature, we have a few markers, like standards for measuring that we always use in our scales.
Yes.
And one of them is the 0 point at which all atomic motion stops.
And we call it the absolute zero.
Right.
Which is equal to?
That's equal to 0 kelvins.
Mm-hmm.
So I'm going to put a line through there so you know it's not the letter O.
Okay.
0 kelvins.
Which is also equal to minus or negative 273
degrees Celsius.
degrees Celsius.
Right. And the way they found this is they put it in a graph, right, where you have temperature and kinetic energy, and they read the temperature going down, 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 down. And so they have to read across here, like, what's it going to be way down here?
Yeah.
Because they never actually measured that. All right. So then I got to clear that writing out of the way.
Okay.
Okay. So we also use water as a reference. When water gets to 100 degrees Celsius or 212,
degrees Fahrenheit.
then what happens to it?
It's called the boiling point
Right.
of water.
So at sea level, water boils at this temperature, boiling point.
Which is 100 degrees Celsius.
Yes, right. And another handy measurement is a freezing point.
Freezing point.
This one's not quite as dependent on altitude as boiling point is. Because in Falcon, water boils at about 93 degrees, 92,
Yeah.
93. So let me put this one back. We have these three values, absolute zero, boiling point of water, and freezing point of water.
Point.
And all of our temperature scales are based on these three values.
Okay.
All of them.
All of them.
Okay, so no matter what units we're using, we're always referring to the same height of mercury on a thermometer.
Okay.
Right. It's just different scale.
Different scale.
Yeah.
Like Fahrenheit, Celsius, or
Right.
Kelvin.
And anybody who's done art classes knows what we mean by scale. If you take something small and make it big, you've changed the scale of that object. Right?
Okay.
You expanded like 2 to 1
2
or
to 1.
3 to
yeah,
1 or
how
whatever.
many times? Okay.
Right. So that's what we mean by scale. Here's our formulas. This is simply the equation of a straight line. Y equals mx plus b. Okay? So where y is our Fahrenheit degrees, Fahrenheit is equal to 9/5 times our degrees Celsius.
Okay.
And then
Plus
we add 32.
32.
So in this case, we're going to multiply first and then add. Okay?
Yes.
So regular order of operations.
Yeah.
Now to convert Fahrenheit to
To
Celsius,
Celsius.
it's going to use parentheses because we want to make sure we do the subtraction first and then do the multiplication.
Yes,
So we have
degrees
these
Fahrenheit
parentheses.
minus 32 multiplied by 5/9.
Right. And
Okay.
when we say multiply by 9/5 or 5/9 in your calculators, you're going to do like this. Let's do one real quick.
Okay.
Say we have 100 degrees Celsius. We know that should be 212,
Okay.
right? Now we're going to multiply that by 9/5 like this. We multiply that by 9. Okay, so we get 900. Okay. Then in your calculator, divide by 5. Okay, and whatever that is.
Yes.
You know, we could work that out.
Okay, let me check.
Sure.
Oh, I have my calculator with 900 divided by 5, and that should be 180.
Okay, 180. All right, now what do we do to this? Now after our parentheses, we add 32.
Plus 32,
Okay.
and that's equal to 212.
Hey, that's the boiling point in Fahrenheit.
Oh, okay.
So when you have a fraction, you multiply by the numerator and then divide by the denominator. This line in your fraction means divide.
Yes.
That's all that means. Okay.
So,
All right.
Okay, one more.
Yep. Now, if we're changing something to kelvins, it has to be in Celsius degrees first.
Okay.
Okay. So then we just add 273.
273.15.
Yeah.
Okay.
Simple. And Kelvin's an absolute zero, so we don't have degrees of change. It's an absolute number, right?
Okay.
So we don't use the little circle.
So we don't put degrees Kelvin, just
Right.
Kelvin.
With Fahrenheit, we use that little circle, and with Celsius, we use it, but not with Kelvin.
Not with Kelvin.
If you did use it, it's not really so much that it's wrong, it's just that nobody ever does it that way,
Yeah.
so it looks dumb.
Yeah.
And we don't want to look dumb. We want to look smart.
Okay, of course, yeah.
Yes. All right, so now let's
Okay,
change.
let's do problems.
We know that Kelvin is equal to Celsius plus
Plus
273.15.
273. Okay.
Okay, but now we're going to Celsius. So C is equal to what? Well, use your algebra, right? So to undo this addition, we subtract both sides. Okay, so to solve for Celsius, we're going to take our kelvins minus 273.15.
1.5.
All right, so now we have a strategy.
So you
Let's
have,
put our numbers in.
Okay.
298
298
minus 273.15.
minus 273.15.
And Mrs. Ooey's running the calculator.
Yes,
What'd you get?
and it's 24.85.
24.85
But
kelvins.
okay.
Don't put no
degrees
Celsius.
no, degrees
Mm.
Celsius.
Yep, we're changing it to Celsius.
Okay. So it means that 298 Kelvin is equivalent to 24.85 degrees Celsius.
Right. And so this 298 is considered to be standard temperature because it's about the same as room temperature, 25 degrees.
25 degrees.
Yeah.
Okay.
Yeah. In fact, maybe now's a good time to teach them our poem. Maybe you don't know my poem.
I don't know that.
Oh, it's great. It goes like this. 30 is hot.
I remember that, but I don't. Yeah.
20 is nice. If you don't know your Celsius degrees, this will help you remember.
Yes.
10 is cool. And 0 is ice.
That's
All
the
right.
degree Celsius poem, right?
Yeah, that's how to remember. How hot is 25 degrees? It's between hot and nice.
Yeah.
Yeah.
Which is not bad.
Yeah. So you know, here wear a t-shirt. Here, you're okay just in normal clothes, right?
Normal, yeah.
Yeah. And then for this temperature, you need a jacket.
Mm-hmm.
And in this temperature, put on your stocking hat and gloves.
Yes.
All right.
Complete gear for
Yes.
ice.
So 37, according to this poem, would be,
Really hot.
yeah, time to jump in a swimming pool. Because 37 is body temperature.
Okay.
Okay, so 98.6 degrees Fahrenheit. If that was our temperature, and we're getting close to that today.
Oh, yeah.
It's-
Almost every day.
Yeah, it's
Ooh.
summertime.
Yeah.
That means it's time to go jump in the pool. All right, let's change it to kelvins.
All right.
All right, Kelvin is equal to Celsius
Plus 273.15.
yeah, 273.
All right. So that's going to be 37
37 plus
plus
273.
273.15. Just wanted to make sure our answer is correct. That's 310.15.
All right, 310.15. And I'm not going to put a circle.
That's
Just put the
Kelvin.
K.
Okay. And put
All
a
right.
box on your answer.
Yes,
Final answer.
because that's the way I like it.
All right.
Okay, we're moving on. Oh,
30 is
wait,
hot,
wait.
20 is nice, 10 is cold, 0 is ice.
Yes, You like that? It's an easy way to remember.
You know what, Miss Gray? If I'm going back to my country, I'm going to be having a hard time with the temperature because we use degrees Celsius there.
Right.
And I'm used to degrees Fahrenheit here.
Yeah,
So-
you've gotten used to the Fahrenheit. Yes.
Okay. Number
So-
3, Miss Gray.
Number 3.
Okay.
72 degrees Fahrenheit is our starting place. And
Okay.
our hint says first change it
First.
to
You're
Celsius.
so nice, Miss Gray. You give them the hint.
I know. Once in a while, I'll be
Okay.
kind to my students.
Okay.
Don't get used to it.
All right.
All right, so how do we relate Fahrenheit to Celsius?
Okay, so we're going
C
to use...
equals, I remember this, C looks like parentheses. So this Celsius one has parentheses in it.
Okay.
So it's F minus 32. And then is it 5/9 or 9/5?
5/9.
Okay, good. I thought so. So we take 72 minus 32.
All right.
Our students could do that in their heads. Times
I know
5
they're
minutes.
good. That's 40.
Okay, so we 5 times
5.
40 is 200
Divided by 9.
divided by 9.
22.22. 22?
22 point.
22.
Oh, I didn't understand. That's what you were saying.
Yeah.
Okay, and that makes sense because 72 is a nice day, right? 30 is hot, 20 is nice.
Hot. Yeah.
Yeah.
Okay.
Okay, so 22 degrees Celsius.
And then now we're
Now
going to the
change to
second one.
kelvins. Kelvins is equal to 273
273.
plus Celsius. All right, so take our 273.15
Plus
and add 2.22.
273.15. 295.37.
295. That makes sense. Because 298 was about 25. And so 295 is 22. Yeah,
Yeah.
that makes sense. Good. Well, we
There
solved
you
that
go,
one.
guys. Example number 3.
Let's try
Now
another
we're
one.
down to number 4.
Number 4. Now we're going 74 kelvins to
Degrees
Fahrenheit.
Fahrenheit.
Okay, so this is working backwards from the last one we did. And I picked this number because this is the temperature of the liquid nitrogen we used in our demonstration.
Oh, I
All right.
see.
Yeah, see how tricky I am?
Yes, you are, Miss Gray.
All right, 74 kelvins is how many degrees Celsius?
Okay.
So Celsius is
Celsius plus
kelvins
minus 273.
273.
Okay.
Okay, so we're going to get a negative number.
So that's 74 minus 273.
Because 74 kelvins is pretty close to 0 kelvins. That's
It's
very cold.
minus or
Minus.
negative 199.15
Wow. 199.15 degrees
degrees
Celsius.
Celsius.
That's pretty cold. Let's see in Fahrenheit. What's the coldest temperature you've experienced in Colorado? In Fahrenheit, would you say?
Oh my goodness. I
With
remember
wind
that
chill
last year.
Yeah, last winter was very cold.
Yeah.
I think it got down to like negative 40
Oh, really?
when we had ice and wind. Negative 40 degrees Fahrenheit.
Yeah.
Ah, that's so cold that we can't even breathe outside without
I
covering
stayed
your
at
face.
home most of the time.
Yeah.
Yeah.
Okay, well, let's see how this temperature compares to the coldest
Okay.
temperature we could tolerate in the Colorado winter. Okay, so Fahrenheit is not the one with parentheses. So it's 9/5
9/5
times
over.
Celsius
Okay, times Celsius plus
plus 32.
32.
Okay, so,
So
we
that's
take
gonna be
9
9
times negative 199.15.
199. Oops. I'm confused.
Okay, so
Sorry, Miss Gray.
that's all right.
Times negative 199.15
Okay, then hit enter and then divide that answer by 5.
divided by 5.
Good, hit enter.
All right.
And then add 32 to that
Plus
number.
32.
Yes.
That's negative 326.47.
Yep.
Wow.
That's way colder than this
Oh,
temperature we
yes.
talked about.
Yes.
There's no way we could tolerate that.
I know.
And that's why our students will not put their hands inside the liquid nitrogen, because if they do, it will instantly freeze the tissues in their body.
Huh.
Okay, so I let them help me with the demonstration, understanding that if they touch something this cold, they won't do it for long because it'll hurt.
Yeah, just do it quickly.
Right, so this was our temperature of the liquid nitrogen.
Yeah. And they get to experience that demonstration, right?
Yes,
In
right.
class. All
Okay,
right.
so now let's look at what this means for the phase of matter, because temperature and pressure are both related to the
The
phase
phase
change,
change.
right? So if you had a gas, let's start with gases, all right? A gas is in the vapor phase or the gas phase. Then to change a gas to a plasma, we're going to add energy to it, right? So we're
Yes.
going to increase its energy, and that would ionize
Ionize.
the gas into a plasma.
Okay.
And then to go from a plasma
to
a gas, it's deionization.
deionization.
So make sure you know these vocabulary terms, ionization and deionization.
Ionization is gas to plasma.
Mm-hmm.
Deionization means plasma to gas.
Right.
It's very easy.
Right.
Okay.
So now let's do something they're probably more familiar with now, going from gas to liquid.
To liquid, yes, they're
All right.
familiar with that.
Gas to liquid we call vaporization.
No, it's
Condensation.
Condensation.
I did it backwards. Gas to liquid is condensation, like how water vapor turns into a cloud.
Yes.
Yeah. And then
liquid to gas.
turn liquid to gas.
It's
Oops,
vaporization.
Vaporization, right. Evaporation is one type of vaporization, right? And boiling is a different type,
Different type.
but they're both vaporization processes.
Okay.
Okay, now let's go liquid to solid. To turn liquid water to solid water,
Solid.
we freeze it. So that process,
Put water in the
freezing.
freezer.
Yeah.
It's freezing.
and going backwards, solid to liquid is melting.
Melting.
Yep, we all knew that.
Oh yeah.
The kids know. They're so smart. Okay, let's go from solid to gas. This is one they probably don't think of a lot,
Yeah.
but it happens more than you would think. Like in your bathroom, you may have a cone-shaped air freshener. And
I use that a lot.
right, and when you turn it, it opens it up so you can smell it. Those air fresheners go from solid to gas so you can smell it.
Directly. It doesn't go from solid, liquid, and then gas, right?
Right.
It's solid to gas.
Yes, and that's why it's called sublimation. That's a sublime substance in there.
Yes.
And then to go from gas to solid is called deposition. And what you tend to see there is that it goes from gas to crystals immediately. One example is naphthalene, and another one is iodine crystals.
Yeah.
So those two substances are
Some
what's
bathroom
called-
freshener do that one too. I observed that when it's like it's over and it's ready to put into the can, like
Right, you have to
garbage
throw it in
can.
the trash.
Yeah, I see that there's like solids inside.
Yeah, right. And there's lots of different things that do this. It's just not that common.
Yeah.
You don't interact with those much. All right, so know your vocabulary and what's the terms for each process.
This will come out in the test, right, Ms. Gray?
Yes, of course.
Okay.
And I think that's it for temperature.
Okay.
We're done.
Yay.
See you guys in class.